Welcome viewers. Today I will discuss about the topic trigonometric ratios for some standard angles. In the previous video, I will discuss the T ratio and the relationship between them. Here in this video, we calculate the value of T ratio for some standard angles. In this chart, we can see that the trigonometric ratios for some standard angles. This chart is given in almost all of the mathematics books. But where it comes from? Where this value comes from? The sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2. Where these values comes from? That I will discuss in this video. First of all, we calculate the value of T ratio with respect to angle 45 degree. For this, we have to draw a right angle triangle PQR, where angle R is 90 degree or right angle. And angle P is 45 degree. Angle P is 45 degree. Suppose we have to calculate the value of T ratio with respect to the angle P. So here in this right angle triangle, the third angle Q is equals to 45 degree also, because we already know that the sum of all interior angles of a triangle is 180 degree. So here angle Q is 180 minus 90 plus 45, that is 180 minus 135, that is 45 degree. So here in this triangle, angle P is 45 degree and angle Q is also 45 degree. So in this triangle, the length of QR and PR must be same, because we know that the opposite sides of similar angles must be equal in a triangle. Here the angle is 45 degree and the opposite side is QR, and here the angle is 45 degree, the opposite side is PR. So here we can write that QR, the length of QR equals to the length of PR. Let us assume that the length of QR and PR, that is equals to A. So the length of hypotenuse, that is PQ, is equals to root over of A square plus A square, that is root over 2A square, that is equals to root 2 into A. Now we calculate the value of T ratio with respect to angle 45 degree. From the previous class, we see that the sine theta is equals to perpendicular by hypotenuse. So here in this right angle triangle, if we calculate the value of T ratio with respect to the angle P, so here sine of angle P, that is sine 45 degree, is equals to perpendicular with respect to angle P, that is QR, divided by hypotenuse, that is PQ. The length of QR, we assume length of QR is A. So here QR equals to A and PQ equals to root 2 into A. So here we can see that sine 45 degree is equals to 1 by root 2. Similarly, we can calculate the value of cos 45 degree also. So cos 45 degree is equals to base by hypotenuse. So here with respect to angle P, PR is the base. So PR divided by hypotenuse PQ. So equals to PR is equals to PR is equals to A divided by PQ is equals to root 2 into A, that is cos 45 degree equals to 1 by root 2. From these two values, that is sine 45 degree and cos 45 degree, we can calculate the value of tan 45 degree also. We know that tan 45 degree is equals to sine 45 divided by cos 45. Sine 45 divided by cos 45 degree. So sine 45 degree is equals to 1 by root 2 and cos 45 degree is 1 by root 2. So tan 45 degree is equals to 1. Similarly, we can calculate the value of T ratio with respect to the angle 30 degree and 60 degree also. For this, we have to draw a equilateral triangle. Suppose this is a equilateral triangle where PQ is equals to QR is equals to PR equals to, for say, 2A. We know that all angles of an equilateral triangle is 60 degree. So here angle P is 60 degree, angle Q is 60 degree and angle R is 60 degree also. Now we draw a perpendicular from point P to the side QR. Suppose this point is S. From this figure we can see that PS is perpendicular on QR. So angle PSQ equals to angle PSR equals to 90 degree. So here angle PSQ is 90 degree and angle PSR is 90 degree also. So from this triangle PQS, we can see that angle QPS is 180 minus 90 plus 60, that is 180 minus 150, that is angle QPS is 30 degree. Similarly, from this triangle PSR, we can see that angle SPR is also equals to 30 degree. From the properties of equilateral triangle, we know that the altitude or height or perpendicular of a equilateral triangle is equals to its median. So here S is the midpoint of QR and PS is the median. So here S is the midpoint of side QR. So from this we can write QS is equals to half of QR. So QS is equals to half of, total side is 2A, so QS is equals to A. From this figure we can see that in triangle PQS, PQ is 2A, QS is A. So we can calculate the value of PS from Pythagoras theorem. So from Pythagoras theorem we can write that PS square plus QS square equals to PQ square. So from this equation we can get the value of PS. So here PS square equals to PS square is equals to PQ square, that is 2A square minus QS square, that is A square. 4A square minus A square, that is 3A square. So the value of PS is equals to root 3 into A. From this figure, we can see that in triangle PQS, PQ is 2a, PQ is 2a, PS is root 3 into a, and QS is equals to a, QS is equals to a. From this right angle triangle PQS, we can calculate the value of T ratio with respect to angle 30 degree and angle 60 degree also. If we calculate the value of T ratio with respect to angle 30 degree, then sine 30 is equals to perpendicular by hypotenuse. Here, with respect to angle 30, perpendicular is QS and hypotenuse is PQ. So, sine 30 is equals to QS divided by PQ. That is equals to A divided by PQ, that is 2A. That is sine 30 is equals to half. Similarly, we can get the value of cos 30 also. Cos 30 equals to base by hypotenuse. With respect to angle 30, the base is PS and hypotenuse is PQ. So, cos 30 equals to PS divided by PQ. The value of PS is root 3 into A, that we already calculated. And the value of PQ is 2A. So, the value of cos 30 is equals to root 3 divided by 2. And from these two, we can get the value of tan 30 also. We know the value of tan theta equals to sine theta by cos theta. So here the value of tan 30 equals to sine 30 divided by cos 30, that is tan 30 equals to half divided by root 3 by 2. Half divided by root 3 by 2. So tan 30 equals to 1 by root 3. In this way, we can calculate the value of T ratios for other standard angles also. In this video, we calculate the value of T ratio for some standard angles. In the upcoming video, we do some trigonometric applications. So see you in the next video. If you like my video, please share and subscribe my channel. Thank you.